Hi guys, welcome to my video. In this video, we will talk about another example of ApiBrew usage. With help of ApiBrew, we can create a lot of things. One of these is task scheduler. I will try to build simple task scheduler with help of just ApiBrew. Let's think. We need to build this kind of task scheduler. We want to define our task with this definition, and we want to send this task to ApiBrew, and it will execute our task every 15 seconds, and it will execute some JavaScript code, and also it will create a person. Let's first start with our resources. As you know, in ApiBrew, everything is a resource. For this task, we only need two resources, task and task execution. First, let's focus to task. Inside task needs to have a name, description, schedule, execution, last execution, and next execution. Name and description is already clear. Schedule is in when and in which. Schedule is to understand when this task will be executed, and execution is for how it will be executed. So let's go deeper. The schedule is a struct, and it is referenced to here. Inside schedule, let's say we defined these properties. We defined cron, fixed delay, fixed date, initial delay, etc. And if you want to set up a cron job, we can use this cron expression. If we want to set up fixed delay, we can use this one. It is for fixed date. You can also implement different kind of scheduling mechanism by improving it. Now, the second part is execution. Execution is what to do when the scheduling comes. Inside execution, there are task steps, and execution is list of task steps. A task step has these properties. It has property record and Nano code. It can either execute Nano code or it can create a record. And let's say record has these properties. It has the source, namespace, and list of properties. The source and namespace is if you want to create a record, we need to inform ApiBrew, actually our logic, which resource and which namespace we will use to create this record. Let's say we have a task to execute some code every 10 seconds. It means that every 10 seconds, a new task execution will be created and it will be executed. Task execution basically is every task execution, which happens when the schedule comes to the next execution time. It has these properties. It has task, and it has steps and status. Steps is exactly the same as these steps. It is similar. I just copied it from here and pasted it to here. And status shows what is current step. What's current status for task execution? Is it started, running, completed, failed, etc. After defining our schema, our resources, for next, we are calling generate.sh. Basically, not this one, sorry. We are calling prepare schema. So I'm calling ApiBrew apply -f Just forget. I'm calling this command, and with this command, this resource YAML files is sent to ApiBrew, and ApiBrew is creating these resources for us. We can try it. Yeah. So our resources is created. Now we can see that two tables is created by ApiBrew. Task and task execution. These tables are created because of this resource file. Now, these tables, these resources isn't meaningful at all, because by looking at these resources, ApiBrew doesn't understand what to do. ApiBrew will just create a CRUD for us. You can create task, update task, delete task, but nothing will happen when you create a task. For making it live, for making it working, we need to modify the behavior of this task. If you know, with Nano code, we can modify our APIs, our resources, and we can define the logic what to do when, basically. Now let's see our Nano code. I already implemented Nano code side. As you know, it's taking some time. It took me a couple of hours to implement this task scheduler, and ApiBrew helped me a lot by implementing this task scheduler. Now let's see. First of all, I used TypeScript. As you know, ApiBrew is working with JavaScript, but I use TypeScript here. I configured Webpack. So with the help of Webpack, this TypeScript files is converted to JavaScript files, and they are deployed to ApiBrew with the help of this command. And also, for type safety, I generated these models. How these models can be generated? By simply running this command, shgenerate.sh, the models will be generated. This two command is for this purpose. So, for now, let's deep dive and let's see how our task scheduler works. First, I imported the needed things. I will go to here in next minutes. So we have two resources, task resource and task execution resource, and I called these resources with resource command. You can find information about the resource function in Nano code documentation, but basically it is returning the resource for us, and we can operate on it. I will minimize some functions. I will go deeper in next minutes. First of all, let's say when we create new task, each time when we create new task, we need to compute its next schedule, next execution time. Like when this task needs to be executed next. If you remember, in task, I added next execution. Sorry. Now for computing next execution, I created a function here, and depending on the type of schedule, if it is cron, I created a function to compute next execution for cron. If it is fixed delay, I use this one. If it is fixed rate, I use this one. I will not go deeper in these functions. I will just show them. Maybe you can stop pause video and you can try to understand. But it is basic logic. It is common basic logic. For example, you can search in internet how to compute next execution time in cron or in fixed delay for each algorithm. there are common logic, common algorithm, how next execution time can be computed. For fixed delay and for fixed rate, you can see here. Basically, it is a easy stuff. It is a standard algorithm to compute next execution time. And next, so as we understand, every time new task is created, we will compute next execution time for this task, and we will update this task. So before creating it, next execution time will be set. Okay, now let's go to next. And after it is created or after it is updated, we will have a scheduler where the actual execution will be scheduled. Let's see what is here. After task is created, it will first, it is console log it. It will load the task. It means that the load function is just loading the entity, reloading the entity from database. If the next next execution isn't set or it is in past, we will show a warning and we will reschedule the task. And the reschedule is similar. In reschedule, it is just recomputing execution time and it is updating the resource. Now, it is computing the time from now to the next execution time. Let's say if the next execution time is in 6 minutes, this variable will be 360 seconds. Actually, it is in milliseconds, and you need to multiply it with 1000. So it is the millisecond count from now to the next execution. Second, we are calling set timeout with this time. It means that after this period is passed, this part will be executed. Here, we are creating task execution resource with these parameters. If you remember task execution, when the time comes, it is creating this data, this record, basically. And that's it. There are nothing else. And when task resource is deleted, actually we can see the deletion afterwards. So as you can see, very easily we implemented task resource behavior with Nano code. Now let us go to task execution resource. When task execution resource is created, it means that it is time to execute it. Actually, it is executed even before the actual creation. How it is executed? First, it is checking if it is in pending status or not. If it is not, we are throwing an exception. Second, in a for loop here, for each step of execution, it is checking if it is a record. It is by help of this command, it is first locating the resource. If you remember, we had namespace and resource here. First, it is locating the resource. Second, it is creating record from this resource. But if it is a Nano code, it is executing the code with eval. You can say that this eval function is a bad function. I agree with you, but here this eval function doesn't have any harm, because if you consider that this Nano code is only added by the developer, it means that we will not have any issue here, because the developer is aware of this execution and it is solely added by the developer. So it is not user code, it is a developer code. Here we are updating the execution status. If it has an error, we will make it failed. And at the end, we are rescheduling the task. And that's all. We also have one code logic here. Let's say we scheduled new task. After that, our application is restarted or crashed. Every time application is started, all Nano codes is automatically started by ApiBrew. It means that when our application is started, this whole logic will be executed. Here, to continue previous tasks, we need to schedule them. So it is taking the tasks, and for each task, it is rescheduling the tasks. So that's all. Now let's try to test it. We can deploy our code with npm run deploy, and it is deployed. Here we can see that, by the way, I run ApiBrew in my local computer. You can clone ApiBrew and you can run on your computer, or you can use Docker image, or the better variant, you can use ApiBrew website and you can create new instance for you and you can use it. Now, as you see, our JavaScript Nano code is deployed to our application. Now let's test it. For creating new task, I created this YAML file, so I can execute this YAML file and it will create new task for me. So we executed new task. As you can see, every 5 seconds it is executing these two steps. First it is calling Nano code, and second it's creating a record. Let's see. It is hello world. It's fine. I enabled debug logging and there are lots of logs. Here you see that it is this log is written to console, and it is by this code, by this Nano code. Besides that, every time we insert a new person to the database, our task is created. Every time new person is created, yeah, and we have task executions here. And we have next execution is changing every time, and last execution is changing every time. And with help of ApiBrew, we implemented task scheduler. Without ApiBrew, we should do a lot of other things. Just ApiBrew made our implementation way easier and very in a standard way, because it is already creating Swagger for us, and yeah, and we can use this Swagger to interact with ApiBrew, and we can easily use it. So that's all. Thank you for watching.